And that brings us to pitfall number 2. We're going to digress for a moment here to talk specifically about the label and the meeting of the MIL Standard 130 requirements, particularly the environmental conditions in which these physical items are being exposed to, depending upon what it is you're manufacturing. To begin with, you have to mark your item that in a permanent way so that it lasts throughout the product's life cycle. I'm going to jump right down here to the biggest factor is not only the affix method you use, whether it's a permanent adhesive or whether you're riveting an item on a data plate, but the environmental conditions in which this is exposed to. Is it being exposed to some kind of acid wash process? Is it being exposed to sandblasting, salt spray? What other conditions will it need to withstand? And how long will the life of that asset be? Is it a typical 3-year life cycle? Is it 10 years? Is it longer? It obviously has to be difficult to be damaged or destroyed. When you encode with a machine-readable barcode, you're assuming that the barcode scanners on the other end can read that, whether it's day 1 or the second to last day of that particular item's life cycle. That barcode needs to be read and readable. Where do you put the mark placement? That has to be part of the consideration based on some engineering input typically within your organization. The size of the mark can in itself fluctuate based on the construct that's being chosen for you. So it can swell greater typically if you're using a construct number 2 barcode versus a typical barcode number 1. And you always have to consider that limitation in real estate on that label or plate. The last thing you'll think through is the product integrity, making sure that when you affix a label or plate, it does not disrupt the form, fit, or function of that particular item that you're marking and shipping off to the government. Choosing a label or plate can involve an assessment of numerous material types. I'm going to start with the most durable that you would want to consider. We call this a photo-etched aluminum, and we have facilities here at A2B Tracking that can manufacture any kind of photo-etched aluminum at various thicknesses of a plate. It's got great durability qualities. It's printed using a metal photo process, and the application is fantastic for the external, any outside uses of any kind, in addition to areas where things can get very, very hot, like an engine compartment, for example. The next down in terms of ability to endure wear and tear is the polyacrylic. That's a medium to high wear and tear in terms of durability, and that more often than not involves using a print method using a YAG or a CO2 laser. Rough industrial environments, small arms, weapon systems, very good for printing labels on demand, on site at a facility using laser technology. Metallized polyester has low to medium durable requirements, and you can use very simply a thermal transfer printer. That's going to go more often on electronics. Warehouse textured materials, powder coated surfaces. And then the last on the list would be your basic polyester. Maybe the computer in which you're watching this session has numerous asset tags or polyester tags already on them. Low wear and tear, thermal transfer printed, easy on demand. And you can see some samples of the polyester here. Then we move to a polyacrylic, and then finally an aluminum plate. And you can see what the contrast looks like depending upon the material type you might use. Now, after you've considered the material type you may want to mark to, you also need to think about the data and how to get that data conforming to the MIL standard in the right format so that it can get printed correctly and output to the device correctly. If you're considering the use of construct number 1, then your contract may speculate that or specify that you need to serialize within your enterprise identifier. Because you use your enterprise identifier, you can control that serialization process. Or if you're also manufacturing items, oftentimes the manufacturers and the engineers like to include a part number, batch, or even lot number. And that would demand the use of construct number 2. So you're serializing within the part number as it relates to your enterprise ID. Again, using your own enterprise ID allows you to control that whole serialization scheme. You can create and manage your UIDs as a matter of using some kind of import process. You can adopt a serialization strategy and maintain that strategy so you don't create duplicates downstream. And you ought to be invoking a practice where you scan the UIDs once they've been created to make sure commercial off-the-shelf scanning technology can scan and read that particular barcode. But there's a more scientific way to do it called verification, which we're going to talk about in just a moment. Before I go there, let me introduce your options for creating these marks. You can print these labels or plates in-house within your own facilities. In this case, we call that in-house production. Or you can outsource that capability to a company like A2B Tracking, who has all of the internal marking and label material capabilities to really virtually create any label and plate on any kind of material type that you can imagine. But let's talk about the balances between why you would want to go one versus the other. In an in-house production environment, very often you're going to be able to print it on demand right there, perhaps near a production line, or where you're assembling these items, and it's very convenient to have that label or plate printed within your facility. Product volume can become a consideration. When we see organizations getting into the hundreds, if not thousands, of UIDs on an annual basis that they will want to create, then it really does start to make sense from a return on investment instead of outsourcing it, bringing it in-house. It requires some capital budget to create an infrastructure for these marking devices and to train personnel to get them understanding the military requirements. And to that end, that's why I bring up here the MIL Standard 129 and 130 references for shipping labels and for marking of data plates. That kind of expertise is critical to making sure that when you do it correctly before items are going out the door. From an outsource perspective, you want to find an experienced vendor. There are numerous vendors that are out there at greatly varying levels of understanding of all these requirements. Many of them have the basic understandings of creating a data matrix barcode, but we're not so convinced that they all have a clear understanding of all of the certificates of conformance that have to go along in the verification and validation. One of the main issues we see for most organizations is lead time. How long from when I get you the data, they say, to when you can print or create those marks and ship them to our doorstep. So you want to assess the lead times because that is also a key differentiator across many organizations. How do they require you to submit the data to them and get proof approvals throughout the process to make sure that when you get your label and plate created, it's exactly to the specification of your engineering group? And then, do they offer a data registration service where they will in fact report this data for you up to these government systems? If you're doing it in-house, you've got to also understand the difference between validation and verification of that barcode or the IUID mark. We refer to it loosely here as the difference between spelling and penmanship. If I'm validating for the format of that barcode, I want to make sure that the specific spelling is correct. Obviously not correct in the example I'm giving here. That's what validation looks to confirm. Verification, on the other hand, wants to verify readability of that barcode so that the barcode can be reading to all commercial off-the-shelf scanner standards. and that there's a common standard that everybody is working toward for the computer's ability to read, is it legible? And that we refer to more as a check against penmanship. To validate a mark, you do need a very basic commercial off-the-shelf scanner. But that scanner needs to be leveraging either internal software or desktop software or even tablet software that can automatically interpret the syntax and ensure that you're conforming to those right ISO standards that are contained in the MIL Standard 130. Ensure that the mark's been encoded correctly, that the semantics and syntax are right. At A2B Tracking, we want as many barcodes to be conforming to that validated standard as possible, because the more that are obviously in use and active, the better off that the military is in being able to accurately and quickly track and account for inventory and assets. So what we've done is we've actually created some free software where you can plug in a commercial off-the-shelf scanner, one that obviously has to read 2D data matrix barcodes, and be able to provide you a validate check against it. We also have enabled your phone, as if it's an Android phone, to be able to download an app called UID Tracker and use the internal camera on that phone to perform the same kind of validation check. Verification, on the other hand, is different. As we mentioned, it's the penmanship, it's the readability of that barcode. But it ensures that you can read the label or plate across all scanners, meeting that quality or grade associated with the ISO standards that are encoded. For instance, evaluating the readability of the mark in terms of the white on black or black on white contrast, the consistency of the way that the cells are aligned and assembled on the label itself, the element size. Did you actually create a quiet zone so that the barcode is a readable barcode without any other data or human readable information getting in the way? Is there error correction built in? All of those things is what a verifier, similar to what you see below here, will read, and all have to get checked according to the MIL Standard 130.